Hi everyone, this is Mike with a brief video about using the t-distribution in these one sample hypothesis tests. Now we're here in the intermediate hypothesis testing section, and this video will be posted along with the video lessons here in this section. But I also wanted to point out the fact that in the textbook links section, there's a link here that describes some information that may be valuable to you. So this is a document that hopefully you were using for confidence intervals in the last portion of the unit. But at the bottom of this document is some information about hypothesis testing and the choices that you need to make when conducting a hypothesis test. So like confidence intervals, it kind of breaks down to a couple of different things. So the first thing is, are you calculating with a mean or with a population proportion? So if you're talking about a mean, then you're going to be in this portion of the document. And if you're talking about a proportion, then you're going to be using this formula down here for the test statistic. Likewise, the distribution that you're going to use depends on the kind of sample that you've drawn. So if you have a large sample size, say above 100, or you know the standard deviation for the population, this criteria, knowing the standard deviation for the population, is pretty rare, but it's not too unusual to have a large sample size. And so if you have a large sample size or you know the population standard deviation, then you're definitely going to be using the normal distribution. Likewise, you're going to use a normal distribution for claims about population proportions, or p-hat. However, if you're talking about a hypothesis test related to a mean, so again, we're up in this portion of the document, and your sample size is small, or maybe you don't know the standard deviation, or both. Often it's true that we have a small sample size and we don't know the standard deviation. The small n in general is going to be around 100 or less. And in that case, we're going to be using a slightly different set of calculations, because when we have a small sample size, then the distribution that we use is a little different. It's called the t-distribution. And there's information about the t-distribution in the video lessons and in the textbook. Now, the main difference between the t-distribution and the normal distribution is that the t-distribution is a bit more spread out. And when you're using spreadsheets, you're going to use a slightly different command. So instead of norminv or normdist, you're going to be using tdist and tinv. Now, typically in statistics, we use the p-value method for using a hypothesis test or conducting a hypothesis test. So I'm going to show you how to use the t-distribution in order to conduct a hypothesis test, and I'm going to do it using an exercise from assignment number 12. So this is like item number 15. And what makes this one a little bit different from some of the assignment items prior to it, and I think after it, is that you actually are given the data. In some of the other examples, you are not just given the data, you're given actually the mean and the standard deviation. Here, because we're given the data, we have to do those calculations on our own. So we're going to calculate the mean and the standard deviation of these data. So I'm going to copy and paste all that information into my spreadsheet. And I'm going to go ahead and quickly find the mean by using the command equals average. That'll be my mean. And I'm going to find the standard deviation using the command .stdev. And there's my mean, otherwise known as x bar. That's my sample mean, and this is my standard deviation, otherwise known as S. Now, if I want to compute the sample statistic, like it's shown here, sorry, the test statistic is going to be this formula, which is very similar to the one that you used with the normal distribution. The only difference is that instead of a sigma here, this is an S. It looks a little bit like an 8, but it's an S. So it's going to be the mean, the sample mean, minus the population mean, divided by the sample standard deviation, divided by the square root of n. So in this case, that's the sample mean here. So I'm going to say equals, I'm going to say this is the sample mean. And in the assignment question, the hypothesis is that my population mean is actually 87.9. So I don't know that this is actually the population mean, but the hypothesis is that that is the population mean. So I'm going to operate under that hypothesis. So 87.9 is my population mean, and then I'm going to divide by this quantity, the sample standard deviation, divided by the square root of the sample size, which in this case is 6. There are 6 data points. So I'm going to compute my test statistic there. And now my test statistic, remember, is on the negative side because that is the test statistic on the left side of the distribution. I'm going to look carefully at this and notice that my alternative hypothesis is to the left of the mean. So if this were mu greater than 87.9, then I would choose a positive version of that test statistic. But since my test statistic is on the left-hand side, I'm going to go ahead and pick negative 2.96, 96075. Make sure that's right. 075, yep. And now I need to compute the p-value, which basically means I'm going to find the probability to the left of this horizontal location on the axis. But again, because my sample size is so small, I'm going to choose the t-distribution, the student t-distribution, instead of the normal distribution. So instead of norm.dist, I'm going to choose equals t.dist. And then my x value is going to be this value from right here, the test statistic. And in the t-distribution, we have something called degrees of freedom. And the degrees of freedom in this case is always going to be 1 less than the sample size. So in this case, the sample size was 6, so I'm going to choose 5. And I want to calculate a cumulative probability, so I type the number 1. And when I press enter, I'm going to get this value of 0.015746. 0.015746 is my p-value. And I'll fill in the rest of these while we're here. So notice my p-value is greater than my significance level A, alpha, which means I fail to reject the null hypothesis. And the null hypothesis was that the mean value of the population, or the population mean, was 87.9. So we've got a couple of choices here. The sample data do not support this claim that it's less than 87.9. Let's see, there is not sufficient evidence to warrant rejection, so I think this is the one we want to choose because we are not rejecting the claim. But this says the population mean is less than 87.9, so we are not rejecting that claim. I think we want to say this one. There is not sufficient sample evidence to support the claim that the population mean is less than. So there's not sufficient sample evidence to support the alternative hypothesis in this case. All of these are related to the less than 87.9, so that's the alternative hypothesis. I'm going to submit my answer to the question, and you'll notice we got all of these things correct. Now, the question that a lot of people tend to have in this situation has to do with the p-value. So I want to just remind you about finding the p-value. The test statistic involves using that same formula basically as you've been using already. This is an S instead of the sigma for standard deviation. This is the sample standard deviation. So calculating the test statistic is the same, but when you compute the p-value, you want to use the student t distribution, which relates to this function right here instead of the normal distribution. I hope this video has been helpful. Good luck.